kind of got you ready for it coming. And that is, let me ask you this. Do you guys remember the shortcut for doing something like this? Let's see. Yeah. As long as you remember all the coefficients, you'll be okay. Learn from just mistakes. So I go down to this level because it's the fourth power. So this is the 0th power. Because what would x plus h to the 0 power be? Hey, sweet. So that's 0, 1, 2, 3, 4. So it's kind of nice. These will always match this. Okay. You don't have to know this. You never have to use this for me. I don't care. I hope you realize how freaking useful this is. Maybe you'll use it somewhere. So how does this work? Those tell me the coefficients, but how do I build the terms themselves? Who remembers?
Start with the highest one.
Sorry, I know you know. Yeah, so you start with all x's, no h's, and then you go from there. Right? So this will be x to the 4th. I love it. Plus 4, 1 less x, 1 more h, plus 6, 1 less x, 1 more h, plus 4, 1 less x, 1 more h, plus all h's with a 1 in front. So if I wanted to know the derivative of this, using limit definition. We're only going to use a limit definition to prove, we're going to use this from now on to prove rules that we'll then just use directly. Does that make sense? This is a remarkably useful rule. It's a stupid easy rule. It's beautiful. So if I wanted to know this, do you see how that plays in a part of this? So now I've got to do the limit, as h goes to 0. f of x plus h, that's f of x, all over h. Well, I got this here. All over h minus f of x. So again, how do I know I'm on the right track with this? Or at least one little check I could do. The things without h is cancel. So then I'm able to cancel the problem. That stupid thing is a problem. Die. Now, what's the only term that ends up having no h's now? The one that had one h. So this first dude is always going to cancel because it's going to be the function itself. And then the next dude is the only one that has just one h, so it's the only one that's going to be left alive after I apply the limit. So when I apply the limit, all these go to 0, right? So I end up with works two. So let's do it again, but this time we'll do it for x to the n. Where n actually is any number I want up there. We'll build it to there, but let's think of it right now as a natural number. So what would x plus h to the n be? I'm going to need that. Don't freak out. I'm not going to want every term. The only terms I need are this one, because it dies with this one, and this one, because it's the only one that's going to be left around. It's the only one where the h goes away, so that it doesn't go to 0. I don't really care about the first two terms. Yeah. So once I get down to the nth level of of the Pascal's triangle, there's going to be a 1 and then a what? So what's on the second level? 0th first. What's on the second level? Here. Oh, there's a 2. What's on the third level? Here. 3. So what's on the nth level? Here. That's crazy. And then what's here? Well, it's actually combinations. Who gives a shit? Because that term is going to die. Because it's going to have too many h's in it. Do you get the feel for this? I don't want to prove combinatorics to you. I just want to get to the heart of this. It's not a probability class. So this actually ends up being x to the n plus, what's the coefficient? N. X to the n minus 1 times h plus shit that has higher degrees of h, right? Or stuff, if you don't like the word shit. Okay. So let me give you this. Let me give you this handout since I've got all this on this handout. It'll be a little bit easier to look at. Almost. You can keep going. This is an exciting part of this. These little shows it's harder to patch stuff. Okay, so this is very nicely called the power rule. So it's the rule for when you have an expression that has a power of some kind on it. And you can see I pretty much picked up where we left off here. Right, that second level down on that power rule proof. X to the n plus n, x to the n minus 1 times h, plus terms with at least an h squared in it. So when I divide by h, this dies, because I'm going to subtract x to the n. All these are going to lose an h, and this is the only one that's not going to have an h in it. So it's the only one that's going to be left alive at the end. So what does that mean? That means, if I'm given x to the n, the derivative is n x to the n minus 1. So what does it look like happens to make a shortcut out of this? We had to get there a very long-ass way using limit definition, exploring that. But now I can make a shortcut out of this. It looks like the power comes down, and then it goes down by 1. So for example, if I've got did you not get one? Sorry about that. Weird. Oh, I think they're there. Yeah, okay. If I've got this, what's that prime going to be? 8x, do that? Yeah. You. Now the really interesting thing is, by the way, this piece here using Pascal's triangle is called binomial theorem. And you can expand that to include any numbers up in the power. So, if I had this, what would the derivative be? Well, what's the rule? The rule says take the power down and then subtract 1 from the power, right? So what's going to be in front? 1/7. Yeah. Watch a really cool little shortcut. Pay attention. This is really, really, really useful. If I subtract 1 from any fraction to figure out what the numerator is, I do the top minus the bottom. 1 minus 7 is -6. This is -6/7. So any fraction, subtract 1 from it, So if I had the fraction 11/19ths, what would that be minus 1? 11 minus 19 is negative 8 over 19. Hey, sweetie. Just get on with your life. LCD shit doesn't mean shit when you have 1. It becomes that thing. So that's a shortcut. And why is that really cool? I'm always subtracting 1 for this rule. So that's a really good shortcut to know. I like it. I like it. Okay. So now so we got this rule down. I'm hoping. I mean, I don't care what the power is. What's the one power that's a little bit freaky here? It's not really, it doesn't really show up. What if n is 0? Even then the rule works. So what would it mean if n is 0?
There's no coefficient.
Yeah, so I get 1. Right? Well, let's use the rule directly on this. What would the rule say is true? 0 times x to the, which is 0, as long as x is not 0. Right? And why does that make sense? Because this is actually a constant function, and what's true about the slope of a constant function? The slope is 0. I love it. Okay, like it. So what we're going to do now, you're going to see we're going to do this type of thing we're about to do now. We're going to do it over and over. When we learn a new rule, we're going to incorporate some new things to kind of expand it. What if there was, just to give you a little motivation, what if there was a stupid 5 in front or something, 5x to the 4th? Some of you guys know, but right now we haven't talked about what the hell happens. Yeah, you end up multiplying, because if there's a 1 out front, you end up multiplying 1 by that thing, so it should expand to this. So there are some, I've got them listed down here, some simple rules. So if I have the derivative of a sum of functions, and what does it look like happens? What does it look like happen? It looks like d by dx. Distributed. It doesn't, but that's what it looks like. This is called a linear operator. It'll distribute to both pieces. So I have to take the derivative of both of these, which is the sum of the derivative of each. Not everything in the world does that. Right? A very simple example, counterexample about something that doesn't follow this. Square root of 4 plus 9. Is that square root of 4 plus square root of 9? Some of you guys seem to believe so, but is that true? Is the square root of 13 equal to 5? No. So that is not distributive. That radical is not a distributive operator. It doesn't distribute to the parts. But derivatives do. Why does that make sense? Because they're based on the limit definition of stuff. And what's the limit definition have in it? Plus. Or it's like minus, right? So I can distribute across addition, which is what subtraction really is. The second little dude, let me do the same order. Oh, this is basically the one we just did. This guy. The derivative of any constant is 0. And again, any constant function is going to have a 0 slope, so that makes sense. And then we've got, this is the most useful one right now. Constant just comes out of the way. So if I did this, a 4 would come down, x to the third. So since there's a 5 there, 4 will come down, multiply by the 5, it multiplies by what's there, x to the third. Well, that's beautiful. If you think about it, let me just show you. Why does this make sense? And there's that. So what would twice f prime be? It would be twice this. Yeah. And of course, the 2 could just come in and distribute. Because derivatives are based on this combination thing, this subtraction thing, then distribution kind of makes sense. So I can undistribute a constant. I love it. You guys do it. Okay, cool. And then fourth. Oh yeah, so that's the main rule. E by dx, actually now. That means so much x. I like it. Okay, so try those out, those examples down there, try those out on that sheet.